Greetings class, Dr. Williams here with this solved problem video about the intertemporal budget constraint. Let's look at the problem. Ben lives for 2 years. He earns $50,000 during year 1. He's retired during year 2. He can save some of his year 1 earnings and earn 8% interest and spend that money in year 2. Question 1. Devise an intertemporal budget constraint. Question 2, if Ben wishes to spend $20,000 in year 2, how much must he save in year 1? So please pause the video now and work on this problem. When you're done, resume the video and we'll check our answers. Alright, let's do question 1. Look, I already did it. This is what it looks like. I use C2 to represent spending in year 2, which I've listed down here. Hey, don't forget, on a test, if I ask you to define the variables that you use, and you do not do that, you will have point deductions. We don't want that. I've also used C1 to represent spending in year 1. 50,000 is Ben's earnings in year 1. That comes from here. The 0.08 is the decimal version of 8% interest. By the way, you don't need to use C1 and C2, especially if you're typing this. It's kind of a pain to do these subscripts all the time when you're typing. You can use any letters you want, A and B, C and D, doesn't matter. As long as you define the letters so I know what they are, then everything will be swell. Okay, that's question 1. Let's look at question 2. I've put the intertemporal budget constraint over here for our convenience. Let's see. If Ben wishes to spend $20,000 in year 2, how much must he save in year 1? Well, there's a shortcut to answering this problem. If you remember that this whole thing in parentheses is how much Ben saves in year 1. You have to think about it. 50,000 is how much he earns in year 1. C1 is how much he spends in year 1. So if he earns a certain amount and spends some of it, whatever's left over must be his savings. So if you remember that, that is a shortcut. Savings in year 1. That's what we're looking to solve. So solve for this. In fact, we can kind of rewrite the intertemporal budget constraint if you wanted to. Here, let's take it and copy it, and I'm going to paste it down here. See, you could replace the whole thing in parentheses with, savings in year 1. That's what we're trying to solve for. So now, this should be a little easier. We can plug in the number for C2. C2 is his spending in year 2. He wants to spend 20,000. So we can put that in for C2. Here I go. 20,000. Here, let me go down. I'll skip 20,000 equals savings in year 1. Now 1 plus 0.08 is 1.08. Now we can divide both sides by 1.08. 20,000 divided by 1.08 equals, that's the answer, but savings in year 1. So this should make sense. I don't want you to just plug things in mindlessly. He needs to save about $18,518.52. Put that in a savings account. For 1 year, he'll earn 8% interest. The interest will be about $1,500, and he'll have a total of $20,000 to spend in year 2. That's the idea. So it should make sense. One way you can check your work is if you get a really small number like $3,000, you should immediately be thinking that can't possibly be right. He can't possibly save $3,000, earn 8% interest, and have $20,000 to spend. That's impossible. Similarly, if you do some calculation wrong and you get a number bigger than 20,000, like 25,000 or 22,000, you should say to yourself, that can't possibly be right, because he's going to earn interest. He doesn't have to save more money than he wants to spend later, because he's going to earn interest on it. So it's a good idea not to just, as my old professor used to say, plug and chug, just mindlessly know a formula and put numbers in it, because if you make a mistake you won't be able to catch it. If you understand what you're doing, you'll be able to catch your mistake. So there we have it. Our solved problem is complete. Till next time, Professor Williams is saying, have a good day.